Okay, friends, so let's look at some of the basic ideas about electrical power and energy. Now, you might be aware, but lighting accounts for about 20% of the world's electrical energy demand. That is quite a lot. And if we change to LED lighting, that would dramatically reduce that. So, by the way, LED stands for light emitting diode, and we will learn about this later. But LED bulbs use much less electrical energy per second to produce the same amount of light as the traditional incandescent light bulbs. So, we do have this concept of power. So, power is this very idea of the energy transferred per second, or this, it is given by this equation: electrical energy transferred literally divided by the time taken. Now, the amount of energy that is transferred is usually measured in joules. So joules is the unit of energy. Then by that kind of definition, we measure power as joules per second. So that is the rate of power consumed per unit time, or the rate of power itself means per unit time, or it's also known as watts. Watts is what you will come across. Now, if you would like to understand this, let's think about power ratings and why they are important. So if you were to take an example of, let's say, an incandescent light bulb, which gives a certain amount of brightness or electricity, and consumes about 100 watts, that's the rating. And you will find this rating on various bulbs. Now, if this light bulb is on for about 8 hours, how much energy would it transfer? Right? So how much energy would it consume in 8 hours? So we can simply have us, calculate this using this equation. So 8 hours, how many seconds do we have? 60 times 60 in an hour, and 100 is the rating of the bulb. So when you multiply this, it gives us about 3 megajoules. Now, what is interesting is that about 95% of this energy is wastage. So what really happens that it actually, just converts only 5% of this 3 megajoules of energy to provide the light. Rest all just goes in the surroundings. Now, on the other hand, if you think about an LED bulb, it can give you the same amount of output of light with just 18 watts of power consumption. And there are even newer LED bulbs that are coming that kind of consume even less, like 7 watts. Now let us look at another unit of power called kilowatt hour. Now the joule is rather a small unit of, when it comes to measuring the domestic energy demand. We really consume energy much larger. So we need a bigger quantity. So we use an alternate unit of energy, which is called as the kilowatt hour, or kWh. Now, 1 kilowatt hour is simply defined as the power of 1 kilowatt transferring energy for 1 hour. And it is given by this equation. So 1 kilowatt hour is 1000 watts of power consumed for 3600 seconds, or 1 hour. That is about 3.6 megajoules, or 1 kilowatt hour is equal to 3.6 megajoules of energy. So that's useful, as you will have the kilowatt hour coming time and again in different mathematical equations, and it's just the normal terminology that you would even find on your electricity statements. Now let's look at another important concept of efficiency. Efficiency is simply a measure of useful energy. In other words, the efficiency of an electrical device measures how much of the electrical energy supplied is transferred into a useful form. And there are a couple of ways in which we can state it. The first way is just in terms of the energy. So we can say that efficiency is the useful energy output divided by the electrical energy input, times 100, because it's a ratio. So we calculate it in percentage. Similarly, efficiency can also be measured as useful power output divided by the useful power input times 100. Now, if we were to take an example, right, like a typical incandescent bulb which I just discussed about earlier, it basically transfers electrical energy into light as well as heat, right? So 100 watt of light bulb will transfer only about 5 watts as an useful light. So that means that it has only 5% efficiency. On the other hand, if we look at a typical LED bulb, it is about 25% more efficient, which means it converts more of the input energy into useful form. Now, this is a very important concept that, again, efficiency will keep coming again and again in the context of this chapter. So it's good to just understand intuitively what it means. So what are the key ideas that we covered in this video? The first one is that power is the rate of energy transfer in joules per second or watt. The electrical energy is often measured in kilowatt hours, and 1 kilowatt hour is about 3.6 in megajoules, or 3.6 in 10 to the power of 6 joules. And the efficiency of an electrical device is the percentage of electrical energy or power input that is transferred usefully.